So we work with Mary and a working group on what's the trend on how to industrialize and automate and standardize compute in the future. So what I wanted to show you today is a bit an insight of what OVH has done. Like 3 minutes of corporate intro, because OVH, a lot of people in the US hear OV what? So yes, let me. Okay, so the name OVH actually comes from our founders, which is Octave Klaba. He founded the company nearly 20 years ago. First to do web hosting, domain names business. And he was very active on social networks, IRC at the time. That has evolved a bit. And his nickname was Oles Van Orman, which is OVH. And then to be a bit more corporate in French, OVH is On vous héberge, we host you. So that's basically the name of the company comes from. So almost 20 years, we have 28 data centers on 12 sites. One is in Canada, I'll come back on this. It's a family business, self-financed until 2016. In 2016, we brought some investor in, 20% investment from KKR and Towerbrook. KKR is a pretty big investor in technology. And that started an investment plan of 1.5 billion over 5 years from 2016 to 2020. Euros times, you're correct. And this what's important is 98% of our hosting environment is actually free from air conditioning. So it's free cooling through water cooling, plus the rest is used traditional free cooling. Okay, this work or not? Doesn't. Oh, it's working one direction, but not the others. Oh yeah, okay. So that's our footprint for data centers. We started in France. The headquarters in north of Paris. We have three big data centers in France. Our first kind of adventure outside France was Canada. We were like, okay, we have customers all over the world that were consuming our resources in France. But then like for North America, latency, great, but Patriot Act, Cloud Act, well, Cloud Act didn't exist at the time, but Patriot Act, not quite sure. And we wanted to serve this from a hub in North America, so we chose Montreal and Quebec. There was a little bit of affinity with the French language, obviously, but also lots of power. We discussed about power this morning. Cheap power. It's a great location for data center as well. And so in 2017, we expanded in UK, Germany, Poland, Asia, and actually US. And we have a global backbone interconnecting all those data centers. Talking about this backbone, actually, we have 34 points of presence to connect all the data centers together. Actually, our backbone is we use 100G wavelengths between all the continents and between our data centers, which makes our backbone pretty similar to a carrier backbone, actually. I'm sure if we look at our egress capacity, which is 18 terabits, compared to a Bell type of egress capacity, we would be in a similar order of magnitude, I believe. One thing that is we announced at our summit in Paris last October, we actually assembled our own server. I'll show it to you. And last October, we reached 1 million mark. Basically, since the creation of OVH, we've assembled 1 million servers together. Roughly, our kind of rhythm right now is around 100,000 servers a year of assembly. So it's quite significant. And this is normally, sorry. One thing we do also ourselves is like security, anti-DDoS protection. We've developed our own solution that's included in all our products. That's very important these days. And water cooling, I'll come back on that. We have patent on this. In Canada, so we actually bought a former aluminum smelter near the Beauharnois Dam. So for people who don't know Beauharnois Dam, it's on the Saint Laurent River. It's 36 turbines. It's big. Like when you drive on it, you're like, you start and you see, and you start and you continue. It's actually probably 500 meters wide or something. And it's like producing 2 gigawatts. and we just have like the building on the side. It was built during the World War II to build plane for the World War II. So it was very like streamlined kind of building done, like huge holes for like aluminum smelter. And now we're converting that into data centers. We can host like 360,000 servers. At the moment, we host around 70,000 there. So we're like using 25% of the facility. We have also office in Montreal mostly, and in Montreal we actually have also support for the rest of the group. Like when France goes to sleep, Canada wakes up, and then we do a follow the sun strategy. And also now with the boom of like talent here in Canada for new technology like AI, like new type of storage, Canada and Montreal office will be a hub also for the group as a talent R&D center for like database as a service, Kubernetes, AI as well. So very much where we stand here in Canada, and we've been designated as a IaaS leader in Canada by IDC. And what would I say is we're the only non-American global cloud providers operating on the Canadian market with the hyperscale approach. I think I went through that quite a bit already. I'll go fast because basically the product we are providing and our technology, we are a completely integrated model. So we provide you like hardware as a service or a cloud as a service, definitely. So we have actually bare metal here, which is like equivalent to a dedicated server, we say. So you can actually rent a server. It could be like a very simple server. It could be like really complicated servers with a lot of different customization. So if you want like the latest Intel kind of CPU, we can give it to you on that. Basically, your server is delivered to you in 120 seconds through an interface, through a digital interface. You go on the website, you want this configuration, you want this amount of disk, this amount of CPU. It's all go automatically into our system, and 120 seconds after, you have the login password, and you can actually start using the machine. So that's for our dedicated servers, which is a big part of our offering. We also have a very strong partnership with VMware to deliver what we call private cloud. Basically, it's a higher level of services there, where you have what we call pack, where you have like several hosts and storage attached to it, running like the typical VMware vSphere, vCenter type of application on this. We started this 10 years ago. Like 8 years ago with VMware, and we are definitely a trusted partner there. We've actually, I've mentioned that in the main session. We actually bought their operation of cloud services in the US, vCloud Air, that we actually just migrated like to our data centers. They had 7 data centers in different locations, 5 in the US, 2 in Europe, and we actually migrated all the customer over to our data centers. You'll understand why our approach to compute is very different, and in terms of cost efficiency and cost competitiveness, we were able to make like those customers work in our environment, where with vCloud it didn't work out actually. And we also have a public cloud where we use OpenStack, so we have a full suite of different products here. Okay, so that's for the boring introduction. Now, if you're like interested in like how we built our server, our industrial approach, I'm going to show you a picture on how an OVH data center looks like and how we have industrialized our approach. So that's what I call that from bare sheet metal, because we actually have laser cutting the metal to do our own racks, 2 connected servers. That's our kind of model. We need to have the shortest time possible from the time we actually build the rack to the time it's actually connected in the data center and produce revenue. Because we are an infrastructure provider, and this supply chain is actually very critical to it. It's our core business model. So this thing is actually sometimes it's going to get me crazy. Spilling my show. Okay. So this is how it looks inside. So pretty pretty boring, with lights and everything. It's like typical, picture of data center. You see some difference already. We have no raised floor. That's pretty typical. And if I do it like, this is actually in Canada. You see a lot of pipes here. That's actually for the liquid cooling, blue and red pipes. Clearly, we are in industrial buildings. We don't, this is, we definitely optimize everything in terms of containerize, in terms of cost and reliability. So now, what's the journey of a server? I'll do it like this. So I actually start like with robots cutting metal. This is actually, we have a new facility in France, near our headquarters in Roubaix, where we've invested in new robots to actually, and small machines, to actually do our own racks. So it starts with a sheet metal, and this machine is bending everything, and so starting to create the actual form factor of the racks. That's what it is. Then, see, this is kind of the factory. You see the robots on the back. This is actually German technology, and for those kind of machine, they're really, really strong. So, and you start to see pieces of the rack. So now, this is actually our factory. You see, it looks like more like a factory environment. This is planning. We forecast, and then when we need the racks, we actually move the racks in our factory to create those racks. So this is the form factors. It's still, I see you puzzled. That's normal, because you'll see it's a very different rack at the end. Then we do our own server assembly. So a server at OVH looks like this, with the water blocks we've discussed here. We basically, we don't do our own chip, but we buy from Intel, NVIDIA, AMD. We buy motherboard from Supermicro, same thing, Intel, other providers as well. Disk from all the disk manufacturers, Same thing for the RAMs. We put them together. Putting together a server like this is around 40 minutes. And we have a one-piece flow approach in our factory, where we have, bench of people they take this, and we produce 48 of them at a time, actually. Oops. So then we put them in the racks. So the racks actually look horizontal. Why is that? Because we want to test the rack in factory. So this is in the testing bench. And when we're going to arrive in the data centers, we take a forklift, we stack them up, we just put the power, water, and network, and it's ready to go in like a few hours. All the provisioning and all the testing is automated, software defined, because it's this trendy word this morning. And well, we call that automated. We've automated this for a long time, since the very beginning. And basically, you don't need like a technician, an IT technician, to come over and provision that rack. 48 servers ready to go sell. So this is the front, and the back is here. So you're starting to see what's interesting here on the back. What you see here is a rear exchanger door. It's like a radiators, and it removes the remaining heat from the servers. These blue pipes actually here, they are connected to the CPU. Around 70% of the heat is rejected from the CPU or GPU. And the rest, we remove it with this, which basically means your rack is totally autonomous. Like, you don't need to, like, outside this, the air is like back to almost the same temperature as in front. The delta in terms of temperature between front and back of the rack is like negligible almost. And we have water pipes. Then we can remove the heat from the warm water coming out of those pipes with like very simple dry coolers outside. Okay, and then we run a lot of testing. So we basically simulate workloads on our servers, like a real customer, to test the factory test. The idea is we do as much as we can in the factory, so we can send this to data centers and spend minimum time in the data center to configure it. So then we get into a data center. So this is actually in Germany, where we bought a former printing factory. And we basically, it was not in that state. It was like all dirty and everything. So we just put a little bit of paint on it. But then it's pretty much ready to go. Then we will just connect the electricity and the power there. We actually deploy some containers when it's really big. So this is in Gravelines in north of France, where this was too high to manage the air. We need a bit of, or like to manage humidity or dirt and everything. We put like containers. That we do in-house with the robots you've seen, obviously. So you start to get the picture, right? We do a lot of things in-house. And this is how it looks like before we put the racks. So we install all the distribution of power and water. You see the flex on top here. And then you have at the end, like this is a network end-of-row racks. And then we start populating. This is actually our cooling modules, where we just pump out the warm water from the containers, and we send this to an external dry cooler. But our cooling kind of footprint in a data center is super limited, right? That's basically that, actually. So when we get people to visit our data center, they're like, where's your cooling? Well, it's actually, because you do water cooling on the chip, you actually don't need to handle all the air, so you remove a lot of the equipment, actually. Cool. So this is how it looks like with the heat exchanger on the back. And this is how it looked like at the end, actually. So very much this idea of like industrialization, supply chain of racks. This is really, oh, actually, this one is interesting. This picture is in the factory as well, where if you have servers that are damaged or they are like a end of their life as new servers, we have like a reverse supply chain where we get people to knock down the servers, retest the components, and if there is interest to do a second life server, we do that as well. Question so far, that's kind of the first, that's our basic model on how we do data center, and we put our server together to market. I see a lot of puzzle faces, so go ahead. Yeah, go ahead.
So within the one unit, that's a closed, I assume it's a closed loop, and there's a heat exchange with a secondary water loop?
So what's happening is,
the water you're plugging in the facility is a secondary.
This is actually the secondary loop going outside to do a dry cooler to evacuate the warm water. And then you have a closed loop inside the containers with the machine, yes. Okay. So you don't see it here, but you have some, you see it here. You have some pumps here.
And connectivity within the unit is what, 10G Ethernet?
Actually depends. Our older servers, there was 1G we offer. We actually just we just launched a new range of dedicated server where we do 10G to each servers.
Okay, and are you accommodating things like GPUs? Or
yeah, we sell GPU as well. Yeah, so for instance, we are majority Intel based, like everybody else at the moment, but we are introducing a lot of the latest AMD processor. We also do GPU as a service as well, like NVIDIA V100, for instance. Mm-hmm. That we water cool as well. Right. So we take the NVIDIA GPU and we put the water block on this. That's okay, no problem. We actually are working with them on a DGX1, which is the latest kind of beast, where they put a GPU in 2 use. So the consumption could go to 3 kilowatt in 2 use, which is quite a challenge. But same thing, we've actually worked with some of their OEM also to water cool the GPUs from them.
Do you use CoolIT direct-to-chip cooling, or is it your own?
We do it internally, but we've looked at CoolIT systems. Actually, that's what we have the critical mass to do it ourselves, basically. But same thing with. Right now, they're like a rack manifold with like quick connectors for the waters. That's something we are doing inside as well. We're using the same connector as they do. It was talked a lot about Open19 in the main session. They're using the same connector as well, same ID, plug-and-play hardware. And what we're doing is more and more, this kind of quick connection on power, water network. So the idea is when you arrive, if you have to change a rack, a server, you go, it's like automated. Yeah, go ahead.
What's the maximum capacity you have on the rack level defined?
In terms of how much we can cool?
Kilowatts, yeah.
Kilowatt, yeah. So most of our racks are like 4 to 10 kilowatt because that's what the mainstream servers are consuming. But we have racks that could go up to 20, 25. Above 20, 25, it starts to get a bit trickier. Not for the liquid cooling. It's more like the air cooling on the back, like the heat exchanger door, where when you get to much higher density and much higher consumption, we're getting into trouble with the capacity of that.
And what kind of instrumentation you have, like in terms of the power monitoring or the sensors? What do you?
Yeah.
I was
So
going to ask you, do you buy anything from anybody? Or?
no. No. We have developed our own power monitoring sensor and integrated that in our platform. Also, for instance, on the server itself, and that's the beauty of having an integrated model where you have hardware and racks as well. We have an IPMI network that gives us like all the temperature that's happening around the servers and in the CPU and that kind of thing. In terms of data center management information system, we have developed our own internal interface based on open source standards as well. And yeah, we have like software developers and we are technologists, so we have come up with a lot of those solutions very early on. There are solutions we're looking into the market now potentially to complement some of what we've done, because it's clearly not perfect, right? We're still in the growing and maturing phase where we rationalize all our internal system.
There's some hope. There's some hope to sell you something.
Yeah.
Do you manufacture locally to every data center, or do you have a centralized manufacturing?
So we actually have a more centralized. 80% of our manufacturing is done in Croix near Lille, in France, and 20% is actually done here in Beauharnois as well. So in Beauharnois we have a data center, but also a small assembly line as well. And actually, this is interesting because this is part of the supply chain ideas. We manufacture and then we send it right away to the data centers. So we could have said, well, why not giving that to an Asian company and getting a fully integrated racks, and actually transport it would be a long time, and also customizing all the water blocks, etc. That actually we have the capacity to do it ourselves. So economically it makes sense.
Francois, just one question.
Yeah.
So, two questions. So I knew you guys historically from the dedicated server hosting and the cloud model, like we spoke about. You mentioned co-location up there as one of the things you guys do. Is that in existence?
No, sorry. We actually don't do it.
I saw it on the slides.
It's actually, sorry, the slide is about, I'm coming back on it. Today, that's what the world looks like. You have people on premises, colo data centers, and what we can provide is more like a combination of all those products to fit the needs.
Okay, sorry.
So basically, the idea it was to kind of show you how we do it in terms of and why we are industrialized, and we look at an industry approach rather than an infrastructure approach. I think that's important. And we think, the founders, they were engineers from industrial engineers, and you could tell it like Octave's father was a mechanical engineer. He came up with all the cooling stuff. And Octave and his brother had an industrial engineering background. That's why the standardization, automation, fast delivery was their kind of mindset. So coming back to the study, the working group, we've worked with Mary, and the report that will be published soon, very soon. I took this picture. It's going to come. Basically, actually, compute factor is not about the form factor only, right? Or it's not just the fact that we're reusing old industrial building. It's also about a lot of other things. It's automation. We mentioned it here. It's supply chain management, standardization, standardized design, design for building at scale. So I'd like to touch base on a couple of those concepts real quick. And I apologize. It's just going to be fast and maybe just touching on some of those subjects, but happy to discuss during the rest of the day on this, right? There are like 8 dimensions that were identified in the report to industrialize your compute. I'll talk about supply chain management. That's important for us. Standard design. And for us, it's important to have standard design. In power, it's relatively easy. Cooling starts to be relatively easy. Network is actually one thing we also need to crack in terms of how we converge a network for various environments. A public cloud network is not the same as a dedicated server network. When you need to give 10 gigabit to a specific server versus kind of managing like a, sorry for that, Kubernetes stuff on a public cloud, it's a different network architecture. Oops. One thing I wanted to come back on, I think you're getting the picture now, is basically my job is to go from production to delivery to a customer. And if I do my job well, I do all this in less than 2 weeks when the first components arrive in the factory to the time it's actually connected to the in the data centers. And so as you can see here, we do forecasts to kind of build and to buy components with all the people like you guys. We mount on the rack. We do a lot of testing. Then we install in the data centers. We could actually do a bit of what we call customization. So we have standard configuration, but if you want more memories or more performance on the disk, we can actually change that. You have a configurator on the web, and we get like a direct order. It's called a to-do list, where our technician, when you click on I buy a specific disk, will receive that almost right away, and will go run to do it in less than 24 hours. 5 minutes, all right. Hey, that's not fair. And so for us, what's important is quick time to market. We can also modify our platform very fast. We deliver fast also. And what we want to say, it's an innovation in terms of hardware, obviously the way we do the hardware, the way we integrate it, and the business model as well. And I'd like to quote something, Mary, you put in your reports, which is like the opening kind of comparison is like, when you ask, like when Ford invented, or maybe you can tell it better than I do, right?
I think probably some of us in the North American geography know the quote better. So when Ford was asked, if left to their own devices, what would people want? And the answer is that they would want faster horses, when really we need cars. So you need somebody who's driving the innovation who can think outside the box.
Sorry, on my Mac, the format was a bit different, but it was supposed to be boxed in this grid. So this model for us in terms of IT is how to get to the next level in terms of delivery, price point, and answering what I mentioned this morning, like customers that really want, on-demand capacity. The business model, we sell things for like a dedicated server, it's a monthly lease. And if you want to leave that server after a month, well, we'll sell it to somebody, we'll recycle it, no problem, right? It's not like an IT project when you do like a CapEx simulation for 5 years and you're stuck with your kind of hardware for 5 years. No, with us, you take whatever you want. Same thing, same promise as a public cloud or private cloud, right? So we manage a fleet of capacity, definitely. And this is actually an internal drawing. It's not very sophisticated, but it's our kind of our core engine. What it means is we have customer like here, where we have a little bit of stock. Obviously, you can't deliver in 1/22, as I mentioned, if you have a little bit of stock, right? But my job is to minimize that stock, actually, and to make sure that stock is the minimum possible, still to be able to keep the promise of delivering in 2 minutes, like a physical servers. For private cloud, actually, we deliver a full environment with storage, host redundancy, network in an hour, 30 minutes. Our client said your competitor typically takes 3 weeks. So when you say you deliver in 90 minutes, people don't even believe it's actually a physical machine you're delivering, right? Like, well, you're doing something, that's weird. Because usually with the others, you take an order form, then he takes it to the pile and everything, and then eventually the technician will come and install additional host or additional storage. For us, if you want additional capacity on your environment in VMware, yeah, it's maximum an hour, 30 minutes, but sometimes for some storage stuff, it's like 3 minutes. So, and so here, this drawing is about, we have this stock and deliver to customer, but sometimes it goes out also, we need to remanufacture the servers, and we recycle it in data centers, so it's here. And we also prod new machines and prod refurbished machine. And when it's really too old, it goes to scrap and brokers. Why I'm showing you this? Because every single day in the morning, I didn't put the number here, right? But I look at the number to make sure the number makes sense, and we run a profitable business on this. So that's an important thing. And I think when you look at IT projects, this is definitely more an industrial supply chain approach, right? And we do that with all the IT platform we have. Another thing in terms of industrialization, it's a very core principle for us is what we call this 1, 10, 100, 1,000. What is all this? We actually have labs where we toy around with a lot of different form factors, a lot of different hardware. That's R&D and design, and we do what we call the prototype. It's the one. And then what we do is, when the one works, we do 10 of them. And we integrate them in the racks you've seen to see if they work out very well. And that's a pre-production. And then we ramp this to a full production mode, right? That's a principle that we've used for like almost 20 years. It's really this, prototype, pre-prod, first prod, and mass production for all our servers, for all our solutions. Very standardized, very automated. This is a kind of bill of material, so and this is the operating procedure for an operator to assemble the servers, right? And we have that for all the servers, for also now all of our infrastructure, the containers and everything like that. And for instance, this is like an inside, like a reference, which shows basically, this is as a Xeon, sorry for 2136. Yeah. I didn't know you were in the room, so I would have put an AMD one here. We have a lot of AMD as well. Has like a 2 NVMe, 512 kind of memory, and then has a 64 gig of RAM. And with that profile, what it does, it goes straight to our billing engine and our web interface. So it's totally integrated, right? So, and basically what this is important is when it's arrived in data centers, on rack unit like 12, row 6, the system is waiting for this. So if it's not this, then we have a check, and it's kind of say, no, it's not the right rack. And so totally automated stuff there. This is a manager, so I was a manager for customers. So in a single view, you have access to all your environment, pretty similar stuff. We do 99% of our business in terms of volumes is through the website and through digital stuff. This is pretty new. I'm showing you that to show you that we're working on the form factor all the time. So this is a picture on how we simplify our racks. The idea is really have a single piping connection, single network connection, single electricity connection. This kind of thing is really the form factors to standardize it. So in every single data center, we can supply chain it. That's pretty much what I had. Again, the racks here. So this is also like the new kind of units of rack we are deploying. Where, as you can see here, we have a gantry, or we say that a framework. We could come here, put this thing here, put all the tube here, and deploy it, and it takes basically maximum 2 weeks. And then what we do is, with a forklift, we come and populate with racks. What you see here as well is those racks could take 1 U, 2 U, 3 U's, 4 U's. You could have a mix of different type of server in there. And And this is like almost 1,000 servers, right? And the distance here is like 6 meters. So here you could probably put like, two of this, 2,000 servers here. So, and what you only need is like a power PDU at the entrance, like chill water at the entrance, and the network fibers, that's it. So plug and play, really plug and play. And we want our server to be pluggable, right? When you kind of like, you arrive, it clicks with the water connector, the network connector, and it's hardware we're doing in-house. We have to finish, so. Yeah. 10 more minutes? Yeah, but I'd like a question, actually, yeah. What I'm showing here is actually, it would be important for the edge stuff is we are modularizing also the infrastructure. Our view is we won't go for like 2 or 3 megawatt increment. We go for smaller increment. Like 500 kilowatt is our typical increment. And what we could do is like with, and we're discussing internally and with some provider on, like here, it's like a container where you have the breakers, all the batteries, all the UPS, and you go and come and dump this. Same thing for the network, same thing for the cooling. There's also generators where you stack them up. The idea is you have like Lego bricks where you can easily, we pre-assemble this, we arrive on site, and same idea of moving from a project view to a supply chain and infrastructure supply chain view. Parting thought, I will just, so I think what, this is kind of the totally automated data centers. This is actually a library tape, right? A tape library, sorry, excuse me. This is actually magnetic stuff here, like old tape stuff. But imagine this with a server. And a robot that would take the server in and out. Actually, we're not that far from that. A lot of the hyperscalers are doing it. We are doing research on this. The good thing also with that is instead of being limited to 3 meters high, you could go a lot higher and start looking like this, actually. Totally automated data center construction. But this is real, I think. I'd say like in a couple of years, and I'm sure some of my competitors are like very close to it, especially people that have done this for a living, not for computer, but for like books and things like this, like Amazon, right? So they're looking probably at that kind of design already. And for that to be a reality, our like autonomous racks is very interesting because you don't have to handle the air. And you could actually plug and play the servers. So I think this is, indeed there's a lot of other discussion around, okay, what about the jobs? Like this is fully automated, but as we discussed here, some of those data centers will need to be fully unmanned, actually. And the FedEx guy could come in and give the server to a robot, and there's a bit of security stuff to look at, but I think this is something that will get worked through. So this was kind of a very high level, a lot of info on how we do data center and how we think about stuff. And the way we measure ourselves is, ability to get services really quick to customer on demand, and also to manage life cycle of hardware, but also infrastructure. That's important as well. We need to be able to reuse infrastructure. I'm getting, so that was very visual sign from Michael. Question, feedback, I'd love to hear your comments.
From a customer standpoint, I kind of wonder, with the liquid cooling, what's the net cost benefit to the end customer? So how do you differentiate at the cost level from a traditional cooling and data center provider?
That's a very good question. And I think, OVH positioning has always been relatively aggressive on price. And I think if you go and compare our pricing to others, we generally win on price. Not because we're low cost and not reliable, but because of this industrialization and the fact that we adopt basically lean industry ways of doing our compute. Now, getting to the cooling itself. when you look at the cost per watt, you divide the cost per watt of building a data center in power, network, structure, civil, and maybe all the BMS and DCIM around. On energy, we roughly the same cost as a typical data center. I've been in the data center industry for 15 years, roughly with the same cost. On cooling, we're way, way below, like a fraction of it. Like in dollar per watt, we're like a fraction of the normal cooling cost for the other guys.
And it's a closed loop cooling system. You're not ingesting water and injecting hot water. You're keeping that same closed.
Yeah, we do evaporation out. No, it's not evaporation. We do dry cooler outside. So it's not evaporation. So that means it's a closed loop as well. It allows us to be super good on PUE because you only have the fans, basically. And we consume very little water. Because we talked about power being an issue. Actually, water is becoming really an issue real quick for people that live in Silicon Valley here. You know, it's already quite, in California, it's quite a topic, right? Or people putting data center in Phoenix, they start to have like water issue. Our water consumption is ridiculous compared to others. From time to time, we change the circuit water for maintenance reasons, but there is actually no loss of water in that.
So has your PUE been coming down over the years? Or are you?
It's been pretty good since the very beginning. I think what helped before we were not doing the rear exchanger door, what we were doing is just like free cooling with like big fans out of the containers. That was a bit more energy consuming. It also depends on the climate. Obviously in Virginia, we're not as good as in like here because it's a bit more humid in Virginia. And from time to time, we have to have like a little bit of chiller capacity to supplement like for peak hours. So that has happened. But yeah, we've been relatively, the 1.09 is like 10 years ago.
So we can
Yeah.
entertain more questions.
Sure.
in the break.
Cool. Thank you. Thanks a lot.